course, that doesn't always happen, does it? Okay, that's good, that's plenty of stuff. And you know, just because everybody else doesn't appreciate mine, appreciation of mine and adhesive and solvent smells, I actually put water in here, okay? Just so nobody can complain, okay? But anyway, so he's gonna simulate putting the primer on right now with his watered down roller. And John is now starting to Rhinobond his plates. What he did is he drug his foot across there, first of all, to be able to locate those plates. I mean, what I find in the field with Rhinobond, the hardest part about putting the system down is finding those plates. You think it's so easy. I mean, how hard can it be to find a plate underneath that membrane? With TPO, it's pretty rigid. It's pretty difficult to feel that plate underneath the TPO membrane, especially when you go with thicker membranes. So what typically a roofer will do, will either drag his foot across it, and when he goes across that plate, you'll see a little telegraphing of the plate through that, and then you know exactly where you need to weld. Either that, or I see people take a squeegee. They take a squeegee and they'll actually drag it down. The important thing, though, is to put those rows of Rhinobond plates in a straight line, because if you just put them wherever, it's impossible to find them. So you want to keep them all in a nice straight line so you know about where they are. So John, that's plenty dry. Come on, John. Roll that in there. It's dry. Go ahead. So now what John's got to do, he's got to pull off his release liner off of the adhesive there. You're not putting your magnets on. I don't know how that's going to work there, John. I'll tell you what. I got to get some real roofers up here. You got to put your magnets on. Nobody come up here and pull these afterwards, okay? He's not going to pass inspection. I hate to tell you, but you know, amazingly, I did a demo like this with our sales reps, and sorry, Dave, and some of those guys were about the same as what John was doing. Is there go ahead and weld. We waited like a minute until they realized they didn't put the magnets on. We went back and put the magnets on, and believe it or not, even after that amount of time, it's still welded. It really surprised me how long they maintain that heat, because they're on top of the polyiso insulation, so it keeps that heat in the plate. Anyway, John's done here with the Rhinobond, and now John's got to go back and roll it. So once again, it kind of just gives you a little perspective of how much faster it is in the labor as well as just the material savings. That's good enough, John. We get the idea. Oh, you're doing it right. Okay, that's all right. Okay, I have one more thing to talk about. Yep, go ahead. Now what I'm going to talk about is, imagine when you're on your roof, we're working on the roof. Keep the noise down back there, okay, guys? Okay, you're up on the roof. There's a lot of safety things up there for the roofing contractor. We have safety lines at the perimeter. We have safety lines around our skylights, around deep sump drains, so that you don't accidentally back off the roof or back into some other type of hazard. So the only issue is once that roofing contractor is off of the roof, then what happens? Then you get a maintenance guy up there. All that safety stuff is gone. That all goes when the roof is complete. So now if I'm the maintenance guy up there and I'm backing around on the roof, there's no indication of where any potential hazard might be. So I really have I really have one choice at this point. I can paint on some kind of safety line, and in order to do that, I have to clean the area where I'm going to paint. I need to put some tape down so it doesn't go all over the place. I need to prime the membrane. I need to put the paint on it. I need to take the tape back off. And then after I do all that, it's still a maintenance issue. I have this paint up there, and it's going to fade over time. It's going to chip. So what I'm going to talk about is a product that Carlisle's just introduced. Go ahead. And it's the TPO pressure sensitive cover strip. And go ahead, Dave. Go ahead, kick that out there. And what this is this a pressure sensitive TPO cover strip, 12 inches wide, that can simply be installed by, go ahead, Tim. First thing we would do, we just clean the TPO membrane with some solvent type cleaner. We put the primer on the membrane, let it dry. Then we roll out our pressure sensitive cover strip like we have right here. Go ahead. And then we take a metal roller and we roll it in place. Go ahead. So this is the resulting project right here. This is 3,100 lineal feet of this product that was installed on a postal warehouse. And you can see how easy that is for somebody who might be on the roof to indicate when he's getting close to some kind of potential hazard. And not only does this work on TPO, but it also works on EPDM. So if you have TPO or EPDM, isn't that a thing of beauty? I mean, to see a TPO product on an EPDM membrane, I love that. So Anyway, so go ahead. And that's just another shot of it on EPDM membrane. And then the even cooler thing about it is that not only does it work on Carlisle TPO and EPDM, it'll work on anybody's TPO and EPDM. So if you have a customer that has a couple different manufacturers' roofs up there and they want to use a product like this, it'll work. Really on anybody's single ply. Everything except for PVC, sorry. Because of the plasticizers, we do have the issue of long-term stability of the adhesive. So it does not work on PVC, but TPO, EPDM, and even Hypalon. It even works on Hypalon if you clean off all the, I will say that, all that chalk. Okay. Go ahead. Sorry. That's what I got. So, I talk fast, but, I get excited and I can't help myself. Anybody have any questions? Yes, sir. I'm gonna walk up so I can hear you. That's a great question. I forgot. The question is there any temperature restrictions for this pressure-sensitive TPO? Yes, there are. With any kind of pressure-sensitive adhesive like that, it is sensitive to colder temperatures. So we say it has to be 50 degrees and rising in order to use this product. So if you're in New England, you're going to have a shorter roofing season where you can use it. So we do want to see at least 50 degrees and rising because that's what really gets you that aggressive bite with the adhesive. Good question. Yes, sir. The other question is this work over concrete? A structural concrete would probably be okay. The issue is on some of the lightweight concretes, because of all the dust associated with those, we would not be comfortable going directly on a lightweight concrete with this product because it's going to stick to the dust. It's not going to stick to the deck. So, yeah.
You don't want to go fire.
The question is, what are we going to use when we go on a re-roof? No tear-off. And because we're not using wood fiberboard. We could use the Denstech product. We could use a Secure Rock product. We could use, am I allowed to say all? Yeah. We could use the Insulfoam product. The Insulfoam product has it's the EPS with the, it has like a fiberglass face. It's a really cool product. It's so that would work as well. So you could use a variety of things like that. Good question. Yes, sir. This right here. The question is, are there any photovoltaic products that this is warranted with? Yeah, absolutely. In fact, if you come by and bring your NASCAR ticket by the Carlisle booth, we actually have a division called Carlisle Energy Services, and Carlisle Energy Services actually works with us with the roofing membrane division of our company to actually put together those different kind of packages with a variety of everything from thin film to like a cylinder type thing to an actual rack mounted system. So yes, we can certainly match those up for a warranty. Yes. Oh, another question. Okay, good one. How do you weld the end laps? And he's right. I mean, you can't. Unfortunately, we can't start the adhesive and leave a tab there on the ends. You got to put an overlay over the ends. We're not doing pressure-sensitive overlays. You actually have to weld an overlay at the end laps. So, good question. I'm sorry? Spot welding? And go over the top, yes. The question is, how long do you leave the weights on for the Rhinobond system? It really doesn't take very long. I don't know if I can give you an exact time, but I mean, I'm saying a minute is more than enough, because what they are is they're aluminum magnets, and they do two things. Number one, they push that in close proximity. The molten adhesive in the bottom side of the TPO or PVC. It's just like when you use a Leicester Veramat. You make that. You need two things to make a weld. You need pressure and you need heat. This is exactly the same way. You get your heat from the induction welder. You get your pressure from that magnet. It holds it in close proximity, but it is also designed to dissipate heat. It's like a heat sink, and it does suck that heat out of there pretty darn quick. Yes.
Still 16 plates
For the grid, you mean?
Yeah. So keep it in a straight line.
Okay. The question is, if you're doing the grid Rhinobond, what's the spacing, or how many plates do you need per insulation board? It depends what rate. Is that what you're asking? It depends what rating you're going for. We can get a 90 rating with. I gotta get this right. With 6 fasteners per 4x8 board. So that's a 90. We get a 120 if you go 8 fasteners per 4x8 board. So 1 every 4 square feet for a 120, 1 every 5.3 square feet for a 90 in the grid type pattern. Any other questions? I'm sorry? Did somebody? Did I miss somebody?
Got it.
Okay. Okay. Yes, sir. These guys, they've got good questions. The question is, when you roll this with a metal roller, do you have to just roll it in one direction, or do you roll it in both? I'll give you my recommendation. The best way I see is to roll it in both directions. That's a great point, because the guys that I see that do a really good job, that's exactly what they do. They'll roll it lengthwise, they'll come back and go crosswise, and that really helps bite that membrane onto the substrate. So that's a really good practice to do, yes. Okay, oh, sorry, one more question? That's okay. On this material? The question is okay, I'm going to take a big chance right now, okay? Because he just said, the question was, how long does it take to actually get a good bond between the pressure-sensitive adhesive and the substrate? And part of it, I'll answer with it depends, because it depends on how hot it is. If it's high outside and this is nice and warm, it will bite a lot quicker. Okay, let's just say, okay, now I'm taking a big chance here because I didn't practice this, okay? Okay, see, so even here at room temperature, after, 15 minutes, 20 minutes, I'm removing most of the facer off of that. And what will happen is after that sun gets on there a little bit, it will really start to bite in there a lot more aggressively than what it is already, because we're talking it's only less than 70 degrees in here, and like I said, it's only been 15 minutes. So it's not really a chemical reaction, it's more just a result of the heat and the pressure to get that to bite into that surface of the board. Okay, I really appreciate everybody's time. Thanks a lot for coming. I love the big crowd. You can't tell, but I really like having an audience, But once again, I appreciate everybody for coming out. Appreciate all the questions. And stop by the booth. We can register to win that NASCAR race. It'll be really cool. So, thanks a lot, guys.